Geometry lesson 2-1. This is the introductory to the part where I mentioned earlier where we're going to probably feel like we're in a writing class. Also, this is very much to do with logic, which is a fundamental basis of geometry. It's very much based on logic and kind of conceptualizing could things be based on other pieces of information. So our first bit here is what we would call a conditional statement. Now we make a lot of conditional statements to ourselves, out loud, to each other. They happen all the time fairly naturally. We maybe don't know we're making a conditional statement, and we might not know the two parts, but we do make a lot of conditional statements. They will have two parts. A part we will call the hypothesis, and a part that we will call the conclusion. Alright? So two parts of a conditional statement. The if-then form of a conditional statement will be if is the hypothesis, then is the conclusion. For example, if it is raining outside, then I will use an umbrella. Now we may not actually use the words if and then, but we look outside all the time and we see that it's raining. We jump to the conclusion that we better get a jacket or we better get an umbrella. So we're using the conditional statement all the time. If I'm late home, my parents will ground me. If I talk back, my parents will ground me. If I miss this shot, my team will lose. Those are all if-then statements. Those are all if-then conditional statements with a hypothesis followed by a conclusion. So we make all kinds of hypotheses when we're talking to each other or we're looking at our circumstances going, boy, if this happens, then we figure out what the conclusion would be. And hopefully if we think about our if-thens enough, we can keep ourselves out of trouble in a lot of different scenarios. Now, the conditional statement itself can be either true or false. Every single conditional statement that we make is not necessarily going to be true. It's not necessarily going to be false. But if it is true, if your conditional statement is true, you must be able to convince it's true for all situations. You can't just make the statement and then not be able to back it up. It must be true in all circumstances. But in order to prove something false, it just takes one counterexample. It doesn't take a repetitive amount of times because the statement is based on one particular circumstance, and I need to prove that it's true all the time for that, and then all I need is one counterexample for that to not be true. Alright, so this is going to be a lot of logic. The converse of a statement, for a conditional statement, still talking about the if-thens, will switch the hypothesis and the conclusion. So we had, if it is raining outside, then I will use an umbrella. The converse just takes those two and switches them around. If I use an umbrella, then it's raining outside. And that's not necessarily true. I could be using it for sun. So switching them around. Hypothesis, conclusion, that's a conditional statement. If you switch the order, and you now have conclusion followed by hypothesis, you've now written down the converse of that conditional statement. The negation is any time we write the negative or opposite of a statement. So if I were to say, if it is raining outside, then I will use an umbrella. I could say, if it is not raining outside, then I will not use an umbrella. I'm just negating both of them, and the opposite of each one of those statements. The inverse. The inverse is the act of negating both the hypothesis and the conclusion of the conditional statement. It will not change the order. So it's just like the example I gave a moment ago where I said if it's not raining, then I won't use a jacket. Remember, the conditional statement originally was, if it is raining, then I will use a jacket or I will use an umbrella. So the inverse just negates each one but doesn't switch the order. So I like to think of them as my hands. Hypothesis, conclusion. The converse switches those. The negation of things is opposite, so the inverse will do this. Alright? So we have a conditional statement, we have a converse, and we have an inverse. And lastly, we have what we call the contrapositive. The contrapositive is the negation as well as the converse. So it's negating the hypothesis and the conclusion of the converse of a conditional statement. So here is the conditional statement like this. This is the converse. This is the conditional statement. This is the inverse. This is the conditional statement, the converse, and that's the contrapositive. So I know that's a little bit crazy with the hand signals, but sometimes it helps to visualize where things are moving to. All right? Equivalent statements. When two statements are both true or they're both false, then they would be equivalent. Equivalent sounds a lot like equal, so equal statements. If they mean the same thing, then they're going to be equal to each other. So here we have an original statement. This would be the if-then conditional statement. If the measure, that's M for measure, of angle C is equal to 140 degrees, then angle C is obtuse. So we have an if-then form, and we have the hypothesis. The hypothesis would be here, that's the hypothesis, and this would be the conclusion. So that's the original statement. Now, if we take that and we do the inverse, remember, takes the original statement and it will change or negate it, which means if the measure of angle C does not equal 140 degrees, then angle C is not obtuse. Now let's look at the first statement. Is it true? If the measure of angle C is 140 degrees, then it is obtuse? Yes. It's greater than 90, less than 180. That's a true statement. If it is not 140 degrees, then it is not obtuse? That's not always true. The measure of angle C could be 130 degrees. That's not 140, but it's still obtuse. So the second statement is not necessarily true. The converse, remember, takes the original statement and switches it around. So whatever was the conclusion is now at the beginning, and the hypothesis is second. If angle C is obtuse, then the measure of angle C must equal 140 degrees. That's not true either. If the measure of angle C were 110 degrees, it would be obtuse. Just because it's obtuse doesn't mean it has to be 140. So far we have a true statement followed by what could potentially not be true and what could potentially not be true again. And lastly, we have the contrapositive. The contrapositive, if you recall, is going to take the original statement, it's going to switch the order and negate it. So we have if angle C is not obtuse, then the measure of angle C is not 140 degrees. The fact that it's not obtuse means it can't be something greater than 90 and less than 180, so it can't be 140. So that is actually true. If we look at this, we would have a true, false, false, true scenario. So just remember, I'm going to say it one more time with the hands. If you think of this as the hypothesis and the conclusion for a conditional statement, if this, then this, right here. So we would say, if it's cold, then I wear a jacket. The converse would say, if I wear a jacket, then it's cold. The inverse would take the original statement of if it's cold, then I wear a jacket, and it would negate them and say, if it's not cold, then I won't wear a jacket. And the contrapositive would take that and switch it around and say, if I don't wear a jacket, then it's not cold. So it's a little tricky, but if you get used to the terminology, it will go pretty well.